Let's start with some data point x. Now imagine a cubic box with sides h and the point x inside it. We can write the volume of this box of side h given by volume v equals h cubed. Now if we are in a d-dimensional space, the volume would be h raised to the power of d. Let's define a function k of u. The value of k equals 1 when all values of u lies between minus half and half, or the absolute value of u is less than half. The value of k is 0 otherwise. This is a d-dimensional hypercube centered around 0. Now similarly, let's define the function k of x minus xn divided by h. This is equal to 1 if the point xn is inside the box with side h around x, and it's equal to 0 otherwise. In this case, we have made the variable u into x minus xn over h, and we have centered the box around the point x instead of 0. Let's look through this a little bit more. Let us try to understand this expression a little bit further. Let's look at the first point x1. We form a box of side h around the point x1. Now the kernel evaluates to 1 since the point x is inside this box. Let's look at x2. Similarly, a box with side h around x2 contains the value of x. So the kernel evaluates to 1. Again, look at x3. The same case, we have a box of side h and x lies within this box, so we call the value of this function, the kernel function, as 1. In the case of x4, we have the box of side h, but the value of x lies outside this box. We call the value of the kernel to be 0. As you may have guessed through this explanation, that this function that we have defined is called a kernel function. In statistics, we use the kernel function in general for many different cases. In this case, we are going to use it to estimate densities.